Hi there, pre-algebra students. Today we're moving on into lesson 2 in our real number system study. Today our unit is going to talk about fractions and decimals. This is going to relate in algebra to finding out rational and irrational numbers. So in order to figure out those things later on, we have to be able to convert fractions into decimals and decimals into fractions. So this is the beginning of that lesson. So everybody should have one of these handouts in front of them. So we're going to kind of go through it and fill it out, and then we're going to convert fractions into decimals, and then we're going to practice converting decimals back into fractions. So we're going to work on this together today. All right, so converting a fraction and a decimal. So values or numbers can be expressed in several ways. For example, a fraction can be represented as a decimal or vice versa. So I can represent a number as a fraction, I can represent it as a decimal, back and forth. They're kind of opposites of one another. So in order to convert a fraction into a decimal, I'm going to divide the numerator, so the top number in our fraction, the numerator, by the denominator. So I'm going to take the numerator, the top number, and divide it by the denominator. So in order to do the opposite, to convert a decimal into the fraction, I put the decimal over, whatever the number is, the decimal over 1, put it over 1, and then I multiply the numerator and the denominator both by 10 until there's no longer a decimal in the numerator. So whenever we're multiplying things by 10, we're making our number bigger and bigger. Then I'm going to simplify, just like we always do with fractions. I have to simplify the fraction. All right, so there's two types of decimals, and again, this is going to be important when we get to algebra and we're talking about whether a number is rational or irrational. So two types of decimals here. So if a fraction converts into a decimal that eventually stops, so let's say we have a fraction, a fraction that is 3/8. We're going to do this in just a minute down here. 3/8 is the same as saying 3/8. How many times can 8 go into 3? So when I look at that, I'm like, oh, 8 can't go into 3 at all. So I have to add my decimal point here, and then anything that I'm going to add after this should be kind of review. I'm going to add zeros after it until I get this to solve completely. When I do that, which we're going to do down here below, this decimal ends up being a decimal that stops at some point, meaning there's no more remainder left. And that decimal ends up being 375 thousandths. And when it stops, there's no more numbers that go on. We call this a terminating. So I know you guys are too young for this, but the terminator, his job was to stop things. So this is a terminating decimal, meaning it stops at some point. Like there's no remainder to our division problem. All right, otherwise, so if it's not a terminating decimal, then it's going to be a fraction that converts into a decimal with a repeating block. Some numbers that repeat. It could be 3 numbers that repeat, 4 numbers that repeat, 1 number that repeats. Due to the fact that it repeats, we call this a repeating decimal. So let's look here at this section here of 6 problems. We're going to kind of do a couple of them together, and then I'll let you do them on your own, and we'll see how we do here. So it says practice converting the following fractions into decimals. Fractions into decimals. So to do that, we have to divide the numerator by the denominator, and then 2 parts state what type of decimal it is. So first we're going to convert, then we're going to tell whether it's terminating or repeating. So in order to do that, we talked about converting a fraction to a decimal. We divide the numerator, the top number, by the denominator. So in this case, when I'm thinking about this number, I'm going to extend my division symbol out because it's going to be a repeating number. 8 cannot go into 3. So in order to make this a number that I can have it divide into, I'm going to be adding some zeros after my whole number here. So I'm going to, all we do when we have a decimal is when we're dividing is we scoot that decimal straight on up. So any answer I have now is going to be less than 1. So I'm going to start dividing 8 into now 30 instead of 3. So that means I have to think of my multiples of 8 and what gets me close to 30 but doesn't go over. So I know that 8 times 3 is 24, and then 8 times 4 is 32. So in this case, it's going to be 3. So now we're just doing the steps of long division of a decimal. So 3 times 8 is 24. When I subtract this, I have to regroup. 10 minus 4 is 6. Bring down the next number, I get 60. So I know 8 times 7 is 56. 8 times 8 is 64. So in this case, it can only go in 7 times. 7 times 8 is 56. I'm going to subtract here. 10 minus 6 is 4. I'm going to bring down this 0 here. And 8 goes into 40 perfectly 5 times. So 8 times 5 is 40. And then if I subtract, I get nothing left. So this here is what kind of a decimal? Is it terminating? It stops at some point, or is it repeating? Well, in this case, we have no remainder here. So this is an example of a terminating decimal. Terminating, it stops. All right, now let's look at number 2. So I want you to, we'll write it out, and then I want you to go ahead and solve this. So we're dividing 16 into 1. Now this one we're going to need a decimal point and some zeros. So again, what we do is we move the decimal point straight up, and then we think to ourselves, how many times can 16 go into 10? 16 into 10. Well, it can't. I couldn't go into the 1. I can't go into this 0. 10 is smaller than 16, so I have to put a 0 here. And then 0 times 16 is 0. So if I subtract, I get 10, and then I had to bring the 0 down. Well, now I can divide, and I can figure out how many times can 16 go into 10. Well, 16 can go into 10. Let's see here. I'll get myself a piece of scratch paper to work this out on. So I just want to show you that we need to be showing our work in math always. So I know that 16 times 1, of course, is 16. 16 times 2 is 32. 16 times 3, 18, is 48. So we are trying to get close to 100. 16 times 4, 64, getting closer. 16 times 5, here we are at 80. 16 times 6, ooh, that's really close, 96. And that's only 4 away, so I know that it can go in 6 times. So if I write out my work there, it makes it really simple for me to just transfer it. So 16 times 6, we just said was 96. 100 minus 96 is 4. And then we're going to bring down that 0. How many times can 16 go into 40? Well, now since I wrote out my facts, I can just look back and I know it goes in 2 times. 2 times 16 is 32. And then 40 minus 32 is 8. And then I'm going to have to bring down another 0 here. 80. So here, having written out my facts, I know that 16 can go into 80 exactly 5 times. So 5 times 16 is 80. I'm going to finish out this problem. And there's no remainder there. So again, we learned that if a fraction converts into a decimal that stops, no remainders, doesn't go on and on forever, again, we call that a terminating decimal. Terminating decimal. All right, now let's look at number 3. Number 3 is the fraction 5/6. So again, to convert a fraction into a decimal, we're going to take the numerator and divide it by the denominator. So here's our denominator, 6. We're going to divide it into 5. And I know that 6 can't go into 5. That's already a 0. And then I'm just going to scoot that decimal up. And then I'm going to add some zeros on here to get us started. So now I'm going to be dividing 6 into 50. So I know 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. So this is going to go in 8 times. So 8 times 6 we just said was 48. 50 minus 48, I'll just show my work, is 2. And then I'm going to bring down that 0. How many times can 6 go into 20? Well, I know 6 times 3 is 18. And that's as close as I'm going to get before I go over 20. 3 times 6 is 18. So I'm going to bring down, regroup. 10 minus 8 is 2. I'm going to bring down that 0. And again, we're at 20. So 6, we know, can go into 20 3 times. And 3 times 6 is 18. So again, if we subtract, we're just going to keep being in this repeating pattern of it going in 3 times and 3 times and 3 times and 3 times and 3 times. The 3 is going to go on forever. There's no way that this is going to work to any other number besides 20. So in this case, when we have a repeating block, this 3 just keeps going and going and going and going and going, we would call this, or title it, a repeating decimal. Repeating decimal. All right, so I want you guys to try 4, 5, and 6 on your own. Go ahead and set those up and solve them, and then classify them as terminating or repeating. So we're going to go ahead and pause the video here. If you don't know all the times tables, then do what I did and write it out so that you make sure that you're getting the right answer. So go ahead and pause the video here and work these 3 problems out, and then come back and we will go over them together. All right, so let's look at number 4. So this is 4/9, and we're converting it into a decimal. So this is the same as saying 9 and dividing it into 4. Here we know that 9 can't go into 4. It goes in 0 times. So we're going to put that 0, and then we're going to scoot that decimal point up. And then here we're going to be adding some zeros along the way. So how many times can 9 go into 40? Well, I know that 9 times 5 is 45. That's too big. 9 times 4, though, is 36. So 9 times 4 is 36. 40 minus 36, we'll regroup and borrow. And 10 minus 6 is 4. And I'm going to bring the 0 down, and I get 40 again. So I just learned that 9 can go into 44 times. 36. 40 minus 36, it seems familiar. 10 minus 6 is 4, and then I bring down another 0, and 9 can go into 44 times. And so this is just a pattern of the same thing over and over and over again. There's not going to be a different answer. There's always going to be a 4 as a remainder, and I'm always going to have to bring down a 0, make it 40. So this is a repeating decimal as our answer. Repeating decimal. And mathematically, something that might be helpful to you is to know that any single digit number, so 4, 5, 6, 7, 8, 9, 1, 2, 3, are all single digit numerators. Single digit numerator over the number 9. So if this was 5 ninths, 6 ninths, 7 ninths, any single digit numerator, top number, over the number 9 is going to be a repeating decimal. So again, that's any single digit numerator over the denominator of 9 is going to be a repeating decimal. So just kind of a shortcut to remember along the way. All right, now let's try this one. This is an improper fraction. We would never leave this way in real math, but they just want us to see what would happen if we're dividing a smaller number into a bigger number. We're going to get a whole number decimal here. And I should have moved that down more on my paper. But 13 is our whole number, and then we're going to have some zeros after the decimal point there. All right, so how many times can 4 go into 1? Well, it can't go in any times, but 4 can go into 13, and I know that 4 times 3 is 12. And then when I say 13 minus 12, I get 1. I'm going to move this decimal point up before I forget. I'm going to bring down my 0. And how many times can 4 go into 10? Well, 4 times 2 is 8. So 2 times 4 is 8. 10 minus 8 is 2. I'm going to bring down the 0. 4 can go into 20 5 times, exactly 5 times. 5 times 4 is 20, and that leaves me with no remainder. I don't need that last 0 there. So this stopped. It went in exactly. There was no remainders. So we call that a terminating decimal. And that's because this number stops. It doesn't repeat on and on forever. All right, our next math problem here, our next fraction to convert into a decimal. We're going to take and divide 9 into 7. I'm going to just get in the habit of putting that decimal after the whole number. And in this case, I know I'm going to have to add some zeros because 9 can't go into 7 at all. So in this case, I know my decimal is going to be less than 1. So thinking about the multiples of 9, 9 goes into 70. So 9 times 6 I know is 54. 9 times 7 is 63. 9 times 8 is 72. So it's going to go in 6 times. 9 times 7. I'm recording this late at night. 9 times 7 is 63. So 7 is going to turn into a 6. 10 minus 3 is going to turn into a 7. I'm going to bring down the 0. So this, I'm already starting to see, again, remember that rule that if I have a single digit denominator over 9, this is going to end up being a repeating decimal. But let's just work it out to show you. So 9, again, is going to go into the same number, 70. It can go in 7 times, and 7 times 9 is 63. And if we regroup and subtract that, we're going to get 7, and we're going to bring down another 0. So this is just going to be repeating a 7 over and over and over again. So if we remember that math rule, that anytime that 9 is a denominator and there's a single digit numerator over the top of it, it's going to be that repeating decimal. Repeating decimal. So that's converting fractions into decimals. So now we're going to do the opposite. Now we're going to convert decimals into fractions. We're going to do the inverse, the opposite. So if we look back at our notes, it says to convert a decimal to a fraction, put the decimal over 1. Put the decimal over 1, make it into a fraction, and then keep multiplying it times 10 until you get, multiply the numerator and denominator by 10 until there's no longer a decimal in the numerator. All right, so we're going to multiply, we multiply both of these times 10. That's going to give us 3 5/10 over 10. Everybody see how we did that? All right, then if we multiply 3 5/10 over 10, and we multiply both of them times 10, we got to get rid of that decimal. We're going to get 35 over 100. 35 over 100. So now we don't have any decimals anymore. So now what we have to do, our last thing anytime we do with fractions, is we have to simplify. So thinking about this and my divisibility rules, I know that 35 and 100 are both divisible by 5. So to simplify this, I'm going to divide both by 5. And 35 divided by 5 is 7. And 100 divided by 5 is 20. So if I convert the terminating decimal into a fraction, I get 7/20. 7/20 is my answer there. All right, now I'm going to take is 275 thousandths. We're going to put it over 1. So let's start by multiplying them both by 10. Here I'm going to get 2 and 75 hundredths over 10. I'm going to multiply it by 10 again. So all we're doing is moving the decimal place over once each time. So this is 27 and 5/10 over 100. Still not there yet. So if I was going to take 27 and 5/10 over 100, I'm going to multiply each of these times 10, and it's going to give me 275 over 1,000. And now I'm going to simplify that. Let's see. I think that I can divide them both by 25. So I'm going to have to work this one out. So let's divide it by 25. So let's see. 25 can go into 27 one time. 1 times 25 is 25. 7 minus 5 is 2. Bring down the 5. 25 can go into 25 one time. 1 times 25 is 25. All right, so 275 can be simplified. Both can be simplified by 25. And that'll give me a numerator of 11. And if I take 1,000 and divide that by 25, 25 goes into 100 4 times. 4 times 25 is 100. And 100 minus 100 is 0. Bring down this 0. 25 goes into 0 times. I gotta include that 0 because I had to bring this number down. So 0 times 25 is 0, and there's no remainder. So 40, 25 goes into 1,040 times. So this our terminating decimal of 275 thousandths is 11/40ths as a simplified fraction. It is a simplified fraction. All right, so now I'm going to take 8 and 12 hundredths. I'm going to leave the whole number alone, and what I'm going to do is convert the 12 hundredths into a whole number. So if we think about that, this is the same as saying 8 and 12 hundredths over 1. I'm going to multiply it by 10. So I'll leave the 8 alone, move the decimal over 1, so now I have 81 and 2/10 over 10. And then I'm going to multiply both of these by 10 one more time to get a whole number. So this is going to be the same as saying 812 over 100. Now, this is an improper fraction because the numerator is larger than the denominator. So in order to solve that, I have to, I'm going to show my work. I guess I'll do it here. So 812 is going to be divided into 100 because this is an improper fraction. That's how we're simplifying it. 812, scratch that. Ignore what I just did, I messed it up. So because the numerator is bigger than the denominator, so I'm going to divide 812 divided by 100. Sorry about that. 100 goes into 812 8 times. 8 times 100 is 800. That leaves us 12. So this is the same as saying 8 and 12 over 100. That's now a mixed number. So I'm going to, pardon my mistake, we're going to scribble that out. So this is the same as saying 8 and 12 hundredths, but the fractional part here still is not simplified. Both of these are even numbers, so I know that I can divide them each at least by 2. Actually, I think I can divide them both by 4, but so we'll leave the whole number alone, 8. 12 divided by 2 is 6. 8 divided by 2 is 50. And then both of these are going to be able to be divided by 2 again. So we'll simplify by 2. If I'd gotten the greatest common factor and divided by 4, I would have been able to simplify this in one shot. So 6 divided by 2 is 3, and 50 divided by 2 is 25. So in its simplest form, 8 and 12 hundredths is the same as saying 8 and 3/25. 8 and 3/25. All right, now number 10 is a little bit different. These are repeating decimals, repeating decimals. So this is the same as saying 888 over, over 1. Sorry, I'm thinking already in my mind what we're going to have to multiply by. So this is the same as saying 888 thousandths over 1. So I'm going to have to multiply both the numerator and the denominator by 10. So that's going to give me 8 and 88 hundredths over 10. I'm going to multiply it again. And that's going to give me 88 and 8/10 over 100. And then if I take 88 and 8 over 100 and I multiply those by 10, I get 888 over 1,000. And then I'm gonna simplify this, and the easiest way to be able to do this is to divide both of these by, let's try, let's just go for 2 right now. So I'm gonna work it out on separate paper. 888 divided by 2 is gonna be 444, and then 1,000 divided by 2 is gonna be 500. So this is going to be the same as saying 444, 500. Let's see, let's divide it by, let's try 2 again. So this is going to be 222 over 250. I think I can divide by 2 again. 111 over 125. Let's see. I think 111 can be divided by 2. 2 can go into 11 5 times. 55 with the remainder of 1. That won't work. All right, so when this does simplify, it should be 8/9. I think what I might have done is brought out the repeating decimal too far. I think I probably could have done it 88 over 100 and then solved it from there. I think that's probably the best way to do that one. All right, now we're going to solve the 11/100th repeating. So this again is a repeating decimal. So here I have 11 over 1. Oh, I know why it's 9. Hang on a minute. We talked already about the fact that anytime you had a repeating decimal that had a single digit on the top, that meant there was a 9 on the bottom. So because this is a repeating decimal, this tells us that 8 was the numerator of the fraction and 9 was the denominator of the fraction. So scratch everything I just said here. And so that's paying attention to our repeating decimal terms. So scratch that. So because I have a number and this same number is repeating over and over and over and over and over and over again, that was that shortcut way of us knowing that 9 is the denominator of our fraction and this number here, this 8, is our numerator. So that's how we got 8/9. So thinking about that, we have this number here 1 is repeating over and over and over and over and over again. Well, 1 is a single digit number. So this is the same as saying 1/9. So we're not going to convert it the way we did up here by multiplying by 10. This is where you have to think of that shortcut rule that 9 is our denominator. All right, and here we are going to convert this into a whole number. This one we are going to do because it is a terminating decimal. So this is the same as saying 5 2/100 over 1. And so that's just kind of creating a ratio there. We multiply it by 10, I get 50 2/10 over 10. And then I multiply by 10 one more time, and I get 502 over 100. So again, that's an improper fraction. And so in order to turn this into a mixed number, to start the simplification process, I'm going to divide 502 by 100. And I know 100 can go into 502 5 times. 5 times 100 is 500. That's going to leave me 2 as my remainder, and so I'm going to turn my remainder into a fractional value. So this is the same as saying 5 and 2 over 100. Because 2 is my remainder, we turn that into a fractional value. And then I can simplify the fractional portion by dividing both by 2. So I'm going to leave the whole number of 5 alone. 2 divided by 2 is 1, and 100 divided by 2 is 50. So it's 5, same as saying 5 and 150th. When you're solving these, because there's so much work that you're going to be showing, it really is best if you put a box around your final answer, so I know exactly what I'm looking at. And it's really important for you to show all your work so that I can go back and look and see and help you make sure that how you're getting the right answers, and if you're getting something wrong, I can look at it and make sure that the work is correct. All right, so now we're going to practice some word problems. Again, this is where we take the learning that we've done, the mathematical part, and we turn it into some real world questions. So I want you guys to read through number 13 on your own and just kind of underline what's the most important part, and then we will go over that. So go ahead, read the problem and underline the most important information. All right, so you should have had time to go through and read the question and think about what is the most important thing and underline. So this says Amber has $5.55 in her pocket. Express this amount as a fraction in simplest form. So I underlined $5.55 and express this as a fraction in simplest form. Simplest form is always going to be very important when we talk about fractions. So in thinking about this decimal, it's the same as 5 55/100ths, and I know when I'm converting a decimal into a fraction, I take that decimal and I put it over the number 1. Put it over the number 1, and in order to get this into a whole number, I have to multiply the numerator and the denominator by 10. So this is the same as saying 55 5/10 over 10, and then I'm going to multiply them one more time, and it's going to give me 555 over 100. And to get this in simplest form, I have to take 555 and divide it by 100. 100 can go into 555 5 times, so that's the whole number of my mixed number. And then 555 minus 500 is 55. So this is 5 and 55 over 100. Now I need to simplify the fraction part. And I can do that by dividing both of these by 5. Yeah, 5 will give me the right answer here. So 5, and then 55 divided by 5 is 11, and then 100 divided by 5 is 20. So in its simplest form, $5.55 in a fraction in simplest form is the same as saying 5 and 11/20. All right, our next problem, go ahead and read it, and then I want for you guys to try and work this one out on your own. So pause the video, underline the most important parts, go ahead and convert this fraction into a decimal, and then come back and see how you did. All right, so you should have had time to convert this. It says Cody's new dog weighs 7 2/3 pounds. Express the weight as a decimal. So in order to do this, we have to take our fraction and convert it into a decimal. We do that again by taking the numerator and dividing it by the denominator. So in this case, we're going to leave the 7 alone because that's our whole number, and we're just going to focus here on this fractional portion of 2/3. So when I'm dividing this, I'm going to take my denominator 3 and divide it into 2. So I already know just off the top of my head that 3 can't go into 2 any times, so this is where I'm going to have to start getting decimals involved. So again, I'm leaving the 7 alone. I don't need to turn it into an improper fraction and then solve it that way. I can just leave the 7 whole and focus really on the fractional part because that's going to be my decimal portion. So 3 can go into 20. I'm looking at the first two numbers. So 3 can go into 26 times. 6 times 3 is 18. Regroup. 10 minus 8 is 2. Bring down the 0. So I'm already starting to think in my mind, I think this might be a pattern because I have the same number showing up again. 3 goes into 20 again 6 times. 6 times 3 is 18. If I keep bringing this down and doing this, I just keep getting 20 over and over and over again. So this is going to be a repeating decimal. We put that sign over the number that's repeating to tell us that this is going to be a repeating decimal here. So I would leave this as 7 and put the decimal because this is now the value less than 7. 7 and 6. I can just do the one number 6, and then because that's what's repeating, you write whatever the numbers are that repeat and then put that line over the top that indicates that this number keeps going on and on forever. That tells us it's a repeating decimal. So it's 7 6/10 is the weight of the dog as a decimal. All right, and our last one, Trish entered a problem on her calculator and gave her this result on the screen. So when she looked, it was 0.1894528, and then this tells us it kept going on and on. So the question is, would this decimal be considered a repeating decimal? Why or why not? So I need to go back and think about, well, repeating means the same block of numbers or group of numbers or the same number repeating over and over and over again. So if I look at this, I need to think, is this a repeating decimal or not? And then I have to explain why. So go ahead and solve that on your paper, and then we will go over it together. All right, so you should have had time to do problem number 15. So when I'm looking at this problem here, I have nothing that repeats. These are all just kind of like random digits. So would this decimal be considered a repeating decimal? No, and no, because there is no repeating block of numbers. There is no block of repeating numbers or repeating digits. Nothing repeats. It's just random numbers. Sometimes they might call those like mumbo jumbo numbers. There's nothing that repeats over and over again. So that is today's lesson. Lots of math, lots of writing out, lots of showing work. We converted fractions into decimals and decimals into fractions to determine whether we had terminating decimals or repeating decimals. We talked about both of those. We also converted terminating and repeating decimals into fractions. Remember, anytime you have a number that's the same digit repeating over and over and over again, the shortcut means that that single digit over 9 is your simplified fraction. We put some into practice, so now what I want you to do is kind of take a couple minutes, the last few minutes of class, and sort of summarize in your own words, what did we learn about today? Once you're done with that, your teacher will pass out to you the homework for tonight, And you can use these two handouts that we just worked on to help you with that. It will be fraction and decimal conversions, back and forth, and then it says record the letter of the fraction that is equivalent to the decimal representation, and it says, just note to self, not every single one of these is going to be used. So complete that, bring it back tomorrow, and then we will go over it tomorrow.